Welcome back to the channel. So today in this video we are going to attempt question number 5 of sets class 11th exercise 1.3 of CBSE mathematics. And the question is, write the following as intervals. So this question is based on yet another concept called intervals. So what are intervals? First of all, we'll have to keep in mind that intervals are defined for real numbers. So to understand intervals, let us take two numbers, a and b. Both are members of real numbers such that a is less than b. So to understand this concept, let us take types of intervals. Type number first is an open interval. So what is an open interval? Suppose we are given with a set where x such that x is greater than a but less than b. We know that here a and b belong to real numbers. So how can this set be represented in terms of interval? So in terms of an interval, this set can be represented as a comma b enclosed in parentheses. Note that the interval is dependent upon the style of brackets. Here in this case, we'll be using parentheses. These parentheses show that this set include all values between a and b, whereas a and b are not included. To understand this, let us draw a number line. Representing all real numbers from negative infinity to positive infinity. Let us take two numbers on this very number line, one somewhere here and other somewhere here. Let the first point be -6 instead of a, and let the second point be 4 instead of b. So as we know that x is greater than a but less than b, which means that we'll be having all values lying between a and b while as the endpoints, they are excluded. So here we'll be having interval of form -6 comma 4 enclosed in parentheses. So here the point to be remembered is that the endpoints are excluded. Towards the second type of interval, here we are having a closed interval. So take for example, we have a set where x such that x is greater than or equal to a but less than or equal to b. So in terms of interval, this set will be represented as a comma b enclosed in brackets. So here again we are using a bracket of different style. So this interval means that all the values between a and b with a and b are included. To understand this, let us again draw a number line. Let us again take two values, first somewhere here and second somewhere here. So let us again take the same values as -6 and 4. So all the values lying between -6 and 4 will be taken in this set with endpoints included. Here one can see that x is greater than or equal to a, which means a is to be included, but x is less than or equal to b, which means that b is also to be included. So here the interval will be -6 comma 4 enclosed in brackets. So these brackets, as stated earlier, mean that the interval is closed. So here endpoints are included. The reason why in first case we used these empty endpoints, and in this case we have used these filled endpoints or solved endpoints. So in first case meaning that the endpoints are not included, and in second case meaning that the endpoints are included. Now let us take two more examples where we are having semi-open and semi-closed interval. So take for example, we have a set where x such that x is greater than a but less than or equal to b. So this set in terms of an interval can be represented as a comma b. From left side the interval is open, which means that we'll be using open interval bracket, and from right side the interval is closed, that means we'll be using closed interval bracket. So let us see how this works. Let us again draw a number line having all values from -infinity to +infinity, all being real numbers. Let us take 2 points, first somewhere here and second somewhere here. Let us take first value as -6 and second value as 4. So here all the values lying between -6 and 4 will be taken, and the second endpoint, that is 4, will also be included. So this set will be having all real numbers lying between -6 and 4 with 4 included. So here the interval will be, -6 comma 4. From left side we'll be having open interval bracket, meaning that -6 is not included, while from right side we'll be having a closed interval bracket, meaning that 4 is included. Similarly, take another example where we have x such that x is greater than or equal to a but less than b. So in this case one can observe that a is included while as b is excluded. As in the previous case, -6 was excluded while as 4 was included. Here in this case a is included but b is excluded. So the interval in this case will be a comma b. From left side we'll be having a closed interval bracket, meaning that a is included, and from right side we'll be having an open interval bracket, meaning that b is excluded. So let us again draw a number line to understand this a little bit more. Here again let us take two endpoints. So first one, let us take it as -6, and the second one let us take it as 4. So here the set will be having all real numbers lying between -6 and 4 with 6 included, meaning that the 6 will also be in this set. So here the interval will be -6 comma 4. From left side we'll be having closed interval bracket, and from right side we'll be having open interval bracket, meaning that the -6 is included while as 4 is excluded. Using this concept, let us solve question number 5. Now let us go through the question once again. Write the following as intervals. So the first part is x such that x is a member of real numbers, where x is greater than -4 but less than or equal to 6. So remember one thing, that less than represents an open interval, while as less than or equal to represents a closed one. This is just a shortcut to be remembered. So in part first, the interval will be represented as -4 comma 6. Here one can see that -4 is not included. That means that from this very side we'll be having an open interval bracket, and also we can observe that x is less than or equal to 6, which means 6 is included. So from right side, we'll be having a closed interval bracket. Part number second. X such that x is a member of real numbers, where x is greater than negative 12 but less than negative 10. This interval is open. So this set in the form of intervals can be written as negative 12 comma negative 10 enclosed in parentheses. Part number third. So here we are having a set where x such that x is a member of real numbers and x is greater than or equal to 0 but less than 7. So one can see that this interval is closed from left side and it's open from right side. So in the form of interval, this set will be represented as 0, comma 7. From left side, we'll be having closed interval bracket, and from right side, we'll be having open interval bracket. Part number last. So here we are having a set x such that x is a member of real numbers, where x is greater than or equal to 3, but less than or equal to 4. So this interval is closed from both the sides. So in this case, the interval will be closed from both the sides, as one can observe that x is greater than or equal to 3, but less than or equal to 4. So this set in the form of interval can be represented as 3, comma 4, and closed in brackets. Moving towards next question. Question number 6. Write the following intervals in set builder form. So this question is somewhat opposite of the previous question. So part number first is negative 3 comma 0. This interval is open from both the sides. As stated earlier, for open interval we use this symbol, and for closed interval we use this one. So let us represent this very interval in set builder form. So here we'll be having x such that x is a member of real numbers, where x is greater than negative 3 but less than 0. Part number second, 6 comma 12. So this interval is closed because the interval is enclosed in brackets. In previous case, the interval was enclosed in parentheses, so this was an open interval. Here the interval is enclosed in brackets. This means that it is a closed interval. So in set builder form, this interval can be represented as x such that x is a member of real numbers, where x is greater than or equal to 6 but less than or equal to 12. Part number third. Here the interval is 6 comma 12. So one can observe that from left side this is an open interval, and from right side this is a closed one. So in set builder form, the interval can be represented as x such that x is a member of real numbers, where x is greater than 6 but less than or equal to 12. Part number last, negative 23 comma 5. So from this very side, this is a closed interval, and from this very side this is an open one, meaning that negative 23 is included while as 5 is excluded. So in set builder form, this interval will be represented as x such that x is a member of real numbers, where x is greater than or equal to negative 23 but less than 5. Hope this makes sense. Do subscribe to the channel for more such content, and thanks for watching.